So what problem is this?
39.
Number 39 on
Page 220.
page 220, number 39. We're supposed to show one side equals the other or something along those lines.
Yeah, verify.
Right, verify the identity. So the idea is we're just going to work with our complicated side.
Mm-hmm.
Now, if you remember, I've talked before about this. We've got sine, we've got cosine. There's no obvious math here, is there? It's not like I can multiply everything by something. There's no obvious math. So if I've already got sine, I've already got cosine. Let's change this into terms of sine and cosine. So you're using one of the identities, one of the quotient identities. So I'm going to keep my sine theta plus cosine theta. And now I'm going to change cotangent into its cosine over sine. Notice I'm not writing the other side at all. Okay? I'm ignoring cosecant for now. I pretend it doesn't even exist. All right, now when I do this, I can simplify this. This is cosine over 1, so I can multiply the tops together. So I have sine theta plus cosine squared theta over sine theta. Now I need, I'm trying to add these two fractions together, or sorry, I'm trying to add these two things together, but since this is a fraction, I need to make this one into a fraction. So I'm going to put it over 1, and then I need a common denominator. So it's going to be sine. I'll multiply top and bottom by sine. So now on the top, I have sine squared. And because the denominator is the same, right, sine here and sine here, I can make it one fraction. So I have sine squared plus, then I have cosine squared on the other side, all over sine. And remember, whenever you see a squared anything, you should check out your Pythagorean identities and see if they help you out. Right. Yep, sine squared plus cosine squared is 1, so I'll write that as 1 over sine. And now let's go back and pay attention to the other side. Now I can pretend like this exists, right? Cosecant. I want to get cosecant. I have 1 over sine, which is cosecant. So that equals cosecant. And we're done. So once again, we're looking at the fact that is there any math I can do here? Okay, that's the first thing you do. You look at your complicated side. Is there any math? What I see as math is that I'm adding two fractions. And so whenever you're adding fractions, you need a common denominator. So that's where I'm going to start. I'm going to get a common denominator. Now, my two denominators, I have sine, and then I have 1 plus cosine. So this left one needs 1 plus cosine. So I'm going to take top and bottom and multiply by 1 plus cosine. And then on the other side, this 1 plus cosine needs a sine. So I'm going to multiply top and bottom by sine. Again, I am ignoring this 2 cosecant theta. I'm pretending it doesn't even exist. Okay, so we have to take 1 plus cosine times 1 plus cosine. This is a box, people, okay? Whenever you have two bubbles that have pluses or minuses in there, you're needing to box this out. So I'm just going to do that over here. I have 1 plus cosine and 1 plus cosine. So 1 and 1 make 1. Then we have cosine, and then cosine here, and cosine squared here. So on the top, I'm going to have 1 plus 2 cosine, right, because I have 2 of these, plus cosine squared. Now I'm just going to point out, I'm not done with that fraction yet, but typically what happens when people do this problem is they'll take the 1 times the 1 and the cosine times the cosine, so they get 1 plus cosine squared. And then they're totally missing this 2 cosine. And so that's why we use the box, to make sure that we get everything multiplied times everything. Okay? And so then you end up with your 2 cosine here, which gets right there. Okay, so this multiplied together gives me this. I still have this multiplication to do, which is sine squared, so plus sine squared. And it's all over the common denominator of 1 plus cosine times sine. Does anybody have any questions right now?
No.
Okay. Can I keep going? Mm-hmm. Okay, so now I'm looking and I'm saying, you know what? There's an identity there, isn't there? right? Cosine squared plus sine squared is 1. So now I have 1 plus 2 cosine plus 1 over my denominator. And, oh my goodness, easy math, 1 plus 1 is 2. So we got 2 plus 2 cosine over 1 plus cosine times sine. And a lot of times people get stuck here and look at it and say, well, I have no idea what to do with this. Okay? But when you're looking at this, you should be saying, you know what, I see a 2 here and a 2 here. I can take out a 2, right? So if I take out a 2, that means I'm factoring it out. It's still there. And what do I have left? When I take a 2 away from this 2 right here, what do I get?
1.
I get a 1, so you still need a 1 there. Plus, and then I take a 2 away from here, and I'm just left with cosine, right?
Yep.
And then on bottom, I have 1 plus cosine times sine. Okay, this is the awesome part. This is my favorite part of doing one of these, when like things happen, like good things happen, right?
Those two divide to cancel, or they make 1.
Right, 1 plus cosine theta and 1 plus cosine theta, they all cancel. So now I have a 2 on top and a sine on bottom. When things start simplifying, it's time to go back and look at the beginning and see what you're supposed to get. I'm supposed to get 2 cosecant. What is cosecant?
Reciprocal of sine.
Reciprocal of sine. And look what I got on the bottom. Sine. So really I do have 2 cosecant, don't I? Because if I move that sign up, or remember this is 1 over sine, so if I want to write that as cosecant, I can. So this is a very strange one for them to ask. It's going to make more sense in the next section, but for right now, them asking us is all they want you to do is they just want you to factor it as much as possible. Okay, you're not solving anything, you're not getting, you know, you're not just getting it to be sine or something like that. You're just factoring as much as possible.
I thought that's what
Okay.
I thought they wanted us to do, is to solve.
Oh, no, we're just factoring. In the future, we'll solve. And we need to be able to factor to solve. That's why they have us doing this right now. So what we're going to do, if you look at this, you'll notice that this is something squared minus something else squared. This is going to be one of those special factoring ones where they cancel things out. So I'm going to put sine to the 4th here and cosine to the 4th here with a negative. And because there's nothing in these two, we need them to cancel out. And that's always an indication, if you need things to cancel out here, that you should make the same thing here and here to give you the sine to the 4th, and the same thing here and here to give you cosine to the 4th.
Okay, so, but when you, how do you get 4 when you to an exponent? You just add them, right?
Yep, you're going to add your exponents. So I'm going to do sine squared and sine squared, because that'll give me to the 4th, because 2 plus 2 is 4. Same thing with the cosine, only one of them needs to be negative. Because then what you'll see is in these boxes, if you were to actually multiply, I'm just going to simplify that. Oops, nobody fixed me. This is not to the 4th, it's squared, right?
Oh, yeah.
Okay, so sine squared, cosine squared. So then you'll see, if I put those there, that we have a sine squared, cosine squared, and a minus sine squared, cosine squared. They'll cancel each other out, so it works out. So what just happened is now this sine to the 4th, cosine to the 4th is now the bubble of these two.
Okay.
So we have sine squared x minus cosine squared x times sine squared x plus cosine squared x. Cool stuff here. What's sine squared x, cosine squared x?
1.
1. So this is all really just 1, right? And 1 times sine squared minus cosine squared is sine squared minus cosine squared. So now we have this. And if the gods were nicer, we'd be done here, right? But they're not. Okay, now I can do it again, right? Because I've got something squared minus something else squared. So I get another box. So we have sine squared here and a minus cosine squared. And we're going through the same process. Because those two quadrants cancel, I want to get the exact same thing. So I'm going to have sine x Then I'm going to have minus cosine x and then a positive cosine x. So that when you multiply these, they're going to cancel out. So then, this right here is going to be the two bubbles, sine x minus cosine x, and sine x plus cosine x. Now, nothing else cancels. There's no 1 here. Sine plus cosine is not 1. It's sine squared plus cosine squared is 1. So this is actually just, we're done with this. This is our answer. So in this problem, we're trying to get rid of the fraction. For some reason, whatever it may be in the future, we don't want a fraction. Okay? So just like when we were working with complex, what you're going to do is you're going to multiply by the conjugate of the bottom. So we're going to multiply by 1 plus cosine y. And then whatever we do to the bottom, we have to do to the top. So the easy part is on top. We're going to take that sine squared. No, I'm not going to multiply them up. I'm just going to leave it as is. Sorry. Okay, I'm going to leave it as is. We might want to multiply it through later, but maybe something will cancel if we don't. So we'll just leave it as is. Over. Now, a lot of times people think that this cancels out completely and you're not going to have a denominator. That is not the case. Okay, what does happen is some things cancel out, but not everything. So we actually have to work this out. And we'll use a box to do that. So then as I multiply it out, we'll see that the diagonals cancel again, right? And so on this one, unlike the last one we were factoring, so our answer was what's out here. This one we're not factoring, we're multiplying. So my answer is what's in here. So what do I have in here? 1 plus cosine squared. So I'm going to go and write 1 plus cosine squared here. It's supposed to be negative, isn't it? Okay, so that's supposed to be a minus there, which means this should be a minus here. Okay, now, what's 1 minus cosine squared? There's an identity in there for us, okay? So we'll work out our identity on the side. Sine squared plus cosine squared equals 1. Now when I look at it, I want 1 minus cosine squared. So I'm going to move cosine squared over. So I'm going to subtract cosine squared. So that gives me sine squared equals 1 minus cosine squared. So now I know that I can replace this with what? Sine squared. I'm going to put sine squared there. So now I get, on top, I have sine squared y times 1 plus cosine y. Over, on bottom, I'm replacing that again with sine squared y. Great things happen now, right? We got our sine squareds to cancel. And my answer is just 1 plus cosine y. And we got rid of that fraction just like we wanted to. Alright, so yes, you were correct. We're going to use the identities. So we have sine squared plus cosine squared equals 1. We want 1 minus cosine squared, so I'll subtract cosine squared from the other side. So then sine squared equals 1 minus cosine. You'll notice I do this every time. It's not just for your sakes. Sometimes your answer is going to be like a negative sine squared. So you just want to be careful. So I do it every time, whether I'm doing it on my paper or I'm showing you something. I do it every time just to make sure I get my signs correct. Okay, so now we're going to replace the 1 minus cosine squared with sine squared.
So just cosecant.
Yep, so it's going to be 2 cosecant squared. So once again, we're looking at a problem where we have a fraction and a non-fraction. So let's make that into a fraction, and then I have to get a common denominator. And all I have to do then is multiply by tangent on top and bottom. So now I have tangent squared x minus secant x over tangent x.
Secant squared x.
Well, that helps if you tell me the right problem. I was just getting worried about where I was going to go with
I
this.
did tell you the right problem. You didn't write it down right after.
How many times did I write this problem down? Like
Once.
3 or 4? Okay, moving on, since we're on video. We've got an identity, 1 plus tangent squared equals secant squared.
Well, what the heck?
Right? Whenever you see squared, think identities of Pythagoras. Okay? So I'm going to move. Oh, you guys are weird. I don't even know if half of this is getting picked up, so it makes me sound weird. So, okay. I want tangent squared minus secant squared. So I have tangent squared. I've got to get secant squared over there. But then I got to get rid of the 1 because there's no 1 here. So this is where the signs really matter here. So I'm going to get rid of the 1, move the secant squared over. So now I have tangent squared minus secant squared equals -1. So that means tangent squared minus secant squared equals -1. So I'm going to take -1 and plug it in there. So now I have -1 on the top over tangent of x. And then if I don't want to fraction it at all, I'll deal with the fact that this is 1 over tangent, so it'd be negative cotangent.